All right, so we're back, and I'm gonna go ahead and talk about the what I find bizarre similarities between mass and gravity versus charge and electricity. And so, just to start, let's just look at this blue mass on the left here, and we'll just say that I have, it's existing at this point in space. I'm gonna draw a couple other points around it just for reference. I'll make a little grid of points around it so that we have something to go based off of. So we're saying that we're looking at this mass, and basically this is just some ball or some sphere. I have it in 2 dimensions, but just imagine it's some sphere out in space, and it's got some mass, and mass is really just a property of the object. So it's a property of the object. Similarly, it tells us something about the object. What does it tell us? Mass is basically a measure of how much matter there is in some object. So it's a property of the object. It tells us something about the object. And what mass tells us, really, it doesn't only tell us something about the object, but it also tells us something about the space around that object, or better yet, the mass influences the space around the object in the form of fields. And so you've probably heard of fields before. Fields are a property of space. They're not a property of matter, but rather a property of space. So there are fields. Fields are basically a representation of what kinds of forces are going to act on other objects in space. And of course, with a mass, especially something like the Earth. So let's just say that this is the Earth for now. We'll just pretend that it's the Earth with a huge mass. The gravitational field in the nearby the neighborhood of the Earth, basically surrounding the Earth, it's overwhelmingly going to be pointing towards the Earth, towards its center, because that's what gravity does. A gravitational field is basically just showing us at each point in space, if I were to place, some small mass there, let's put a little small mass right here, and just let this be my little test mass. If I were to put a little mass right there, the gravitational field basically tells me what is the net force that's acting on this little mass. And so in the neighborhood of the mass, I have, basically this vector, this vector, this vector, and this vector. Obviously, there are infinitely more points around it. But for the time being, let's just say we have those 4. The net contribution of those 4 is going to point towards the center of this mass. So the gravitational field really just tells us, if I were to place my mass right here in space, the force that it would feel would be towards this giant blue mass, which is the Earth. Okay, so very similarly, we have charges, which is another property of matter. I'm going to write charge right here also, which is a property of matter. That's a terrible Y. A property of matter. And the main difference between charge and mass is that instead of telling us, where mass tells us how an object is going to influence the gravitational fields around it, charge tells us how an object is going to influence the electric fields around it. And so in such a case as the positive charge, well, let's just start with the definition of what an electric field is. An electric field tells me, if I were to place a positive test charge somewhere in space, what are the forces that would be acting on that positive test charge? And so for a positive charge, the electric field would be pointing away from the positive charge. The reason being that positive charges repel each other. So again, if I were to take the net contribution of these two basically vectors in my electric field surrounding this charge, my little positive test charge is going to feel a net force pushing it away or repelling it from this positive charge that I have here. And in the opposite case, for a negative charge, the electric field is in the neighborhood around it is going to point towards the negative charge. And again, if I put my little positive test charge somewhere out in space, the two surrounding, the two nearby vectors are pointing towards the middle of this negatively charged particle. And so my positive test charge is going to feel a net force pushing it or pulling it towards the negative charge. And that, that right there is kind of the loose proof that like charges repel and opposite charges attract. And so this is just a brief overview of this. I think I'm going to stop this video here, and then in the next slide, I'm going to kind of even more scary than this, compare Newton's law of gravitation with Coulomb's law, which is going to be relevant to circuits.